Today we're going to discuss probability. Let's first go over some key terminology or key words. So let's look at the PowerPoint presentation. In probability experiments, a probability experiment is an action or a trial through which specific results, counts, or measurements are obtained. The outcome, the result of a single trial in a probability experiment. Sample space, the set of all possible outcomes of a probability experiment. An event consists of one or more outcomes and is a subset of the sample space. The fundamental counting principle is a key concept. If one event can occur in m ways and a second event can occur in 9 ways, the number of ways the two events can occur in sequence is a product of m and n. There are a couple types of probability. There's the classical or theoretical probability, where each outcome in the sample space is equally likely. The probability of an event, E, is equal to a fraction made up of the number of outcomes in the event divided by the number of outcomes in the sample space. Let's distinguish that from the empirical or statistical probability, which is based upon observations obtained from probability experiments and the relative frequency of an event. Very similar formula. Probability of an event is equal to the frequency of the event, F, divided by the total frequency, N. Theory of large numbers. Well, if we had a fair coin, you expect that if you flipped the coin, that it would come up heads 50% of the time and tails 50% of the time. But if you did the experiment 10 times, it might come up 9 times heads and 1 times tail, because you haven't done the experiment in a large number of possibilities. Whereas over the course of time, the probability approaches the theoretical average. So the law of large numbers says, as the experiment is repeated over and over, the empirical probability of event approaches the theoretical or actual probability of the event. And I think lastly, complementary events. Well, let's use this big rectangle as the sample space of events. The set of all outcomes in the sample space that are not included in the event is the complement of the event, denoted as E prime. Well, this box, rectangular box, is probability of all events. The circle represents the probability of a particular event. And if we want to know the complement of that, we want everything outside the circle, but inside the rectangular box. Let's use the study plan to go over some sample problems. Let's try identifying space. Let's look at number 27. Identify the sample space of the probability experiment and determine the number of outcomes in the sample space. We want to play a game of roulette where the wheel consists of the slots 00, single 0, 1 through 37. To play the game, a metal ball is spun around the wheel and is allowed to fall into one of the slots. What is the sample space? Well, sample space is all the numbers 00, single 0, 1 through 37. So I think that is going to be answer C. Let me check the answer. That is correct. Okay. Let's look for another problem. This problem reads, the probability that an event will happen, P of E, is 0.46. Find the probability that the event will not happen. Basically, we're looking for the complement, and the total 100 total probability of all both happening and not happening should be 1. So if we take 0.46 away from 1, we have a calculation decimally of 0.54. Checking my answer, we got that one right. We're going to look for another problem. A realtor uses a lockbox to store the keys to a house that is for sale. The access code for the lockbox consists of 5 digits. The first digit cannot be a 1, and the last digit must be odd. How many different codes are available? Note that 0 is an even number. Okay, we're going to use the fundamental counting principle. This is a 5-digit code. So the first digit can be any number but 1, and therefore there are 9 possibilities. The second, third, and fourth can be any digit from 0 through 9. That's 10 values. So that's times 10, times 10, and times 10. So we have the first 4 digits in the code. The fifth digit must be odd. Out of the digits 0 through 9, there are 5 odd digits. So if I form the product of 9 times 10 times 10 times 10 times 5, I should get my answer. So that's going to be 100 times 45. That's going to be 4,500. Oh, what happened here? We pause the video and find out what I did wrong. Simple little mistake. Your professor can't do simple multiplication. I said 9 times 10 times 10 times 10 times 5. Well, 3 tenths as a product is 1,000, not 100. And 1,000 times 45 is 45,000. Little mistake. We all make mistakes, but we learn from our mistakes. Okay, I'm going to go look for another problem. 18 of 200 digital video recorders in an inventory are known to be defective. What is the probability you randomly select a DVI that is not defective? Well, we can do this problem 2 different ways. Let's calculate the probability that they are defective. So the sample space being 200, the event is 18 out of the 200 are defective. So the probability of being defective would be 18 out of 200. Let's see, that is 18 divided by 200. Decimally, that's 0.09. So if we want the probability that they're not defective, we can subtract 0.09 from 1. Okay, so 1 minus 0.09 is an answer of 0.91. The other way we can do this, let me just see if I'm right. Okay, alternate way of doing this, if 18 out of 200 are defective, how many are not defective? So we need to take 18 away from 200, that's 182. So the probability of being not defective is 182 divided by the total sample space of 200. Let's see what the calculator says now. 182 divided by 200. It says 0.91. So we get the same answer either way as long as you think through it carefully. You are planning a 3-day trip to Seattle, Washington in October. Use the fact that on each day it could be either sunny or rainy, and that each day is equally likely to be sunny or rainy to answer the following question. What is the probability that it rains on at least one day? First day, first and second, or first, second, and third. Let's make a tree diagram. So on the first day, we can be sunny or rainy. Let me, so this might be a little clearer. On the first day, it could be sunny or rainy. On the second day, so the first day we were sunny, but on the second day, we can be either sunny or rainy. If the first day was rainy, on the second day, we can be either sunny or rainy. Let's go to the third day. Well, if we had 2 sunny days in a row, the third day could be either sunny or rainy. If we had a sunny day, a rainy day, the third day could be sunny or rainy. And do the same thing over here. If we start off with a rainy day, we could have a sunny or rainy, and finally a sunny or rainy. Okay, how many possibilities in the sample space? Okay, looks like we got 1, 2, 3, 4, 5, 6, 7, 8. Looks like the sample space is 8 possibilities. Now let's go with the question. We want at least 1 day of rainy. Well, SSS is no rain. SSR is 1 day of rain. SRS is a second time of rain, second event of rain. SRR, that's a third. RSS, that's a fourth. RSR, that's a fifth. RRS, that's a sixth. RRR, that's a seventh. So I think the probability of it raining at least 1 day, probability of at least 1 day is 7 out of 8. And 7 divided by 8 is equal to 0.875. Let me minimize this and check my answer. 0.875. Got it right. I'm going to go look for another problem. So I want to pause. Let's go with this last problem. Use the frequency distribution to the right, which shows the number of voters in minions according to the age, to find the probability that a voter chosen at random is in the given range, not 65 years or older. Well, we want the probability of that event, not 65 years or older. And we need to find the total frequency of the sample space. So I'm going to add up the numbers that I see for the frequency. 7.4 plus 11.9 plus 20.4, 22.9, 56.4, finally 26.9, get a total. So this is my denominator, 145.9. That's the sample space. And we want to find the event, not 65 years or older. So I want to take the 26.9 away from my total that I have. So my numerator, I believe, is 119. Let's see what the calculation is. 119 divided by 145.9. And we need to round this to 3 decimal places. My calculator is giving me 0.81562, but I need to round this to 3 decimal places. So approximately it's going to be 0.816. Good. Let's end the session.